So we talked a little bit about medians as a measure of center, and another word for the median is the 50th percentile. In other words, the median is the number that's bigger than about 50% of the data, and lower than about 50% of the data. And I say about because there could be some ties in there that make it a little bit give or take. But median is about halfway point in the data. Now, if you've spent much time in medical offices, hospitals, education, anything where there's a lot of tests taken, you'll get very familiar with this idea of percentiles. So what is this? Percentiles. It simply put, the nth percentile is the number that puts you above n% of the data. So the 30th percentile is the number that would put you above 30% of the data. The 80th percentile puts you above 80% of the data in the population, or whatever it is that you're studying. So let's take a look at a concrete example. I know that's kind of abstract. Let's talk about heights of adult females in the United States. So the average is 65 inches. And the standard deviation is about 3.5 inches, I believe. And so we get a distribution that looks like this. It's a normal distribution. Now, I do want to be clear, percentiles work with any kind of distribution, not just this bell curve where you have most of the data in the middle and then trail out to the center. But since we're going to be working into this here pretty soon, and there is a lot of data that's normally distributed, let's use this for an example. So first of all, let's take real quick example. I think I am I think 50 or 68 inches. If I were a female, or I could put it like this: I am right here. My height is right here. Here's the average height for females. So I'm a little bit above average. So I'm taller than about 80% of the females, adult females in the United States. This percentile here, notice it's saying the percent that's less than whatever this number is I'm putting in here, is 80%. So I would be 80th. You could also say 81st percentile. That's not a real, some people do one, the other. That's not a big deal. But I would be at the 80th or 81st. Now this is a little weird because I'm not a female, and typically you compare something to the rest of the population you're a part of. So I'm not even sure. Let's see. Do a real quick Google search. So it looks like the males are 70 with a standard deviation of 3. So if I put myself in that distribution, I'm a little below the average, and I would be at the 25th percentile or 26th percentile for height of adult males. So definitely more on the shorter side. Now here's something that's a little tricky. So if you're thinking about what percentile you're at, oftentimes in between, let's say, the 5th percentile and 95th percentile, or maybe even the 3rd percentile and 97th percentile, is kind of considered typical. Like they're not that out of the ordinary. If you're taking a medical test, there's a little range where we see most of the data. And the doctors don't get concerned unless they see your data point out here in one of the tails, in an atypical. So if you were at the 2nd percentile or the 98th percentile, depending on what it is, that could be a good or bad thing. Another thing that's kind of interesting is moving a little bit in your raw score can sometimes change your percentile a lot and sometimes change it a little. So let's say we had a shorter male that was maybe 62 inches. So he's sitting here below the 1st percentile. So about the first, you don't really say the 0th percentile. So let's say he's at the 1st percentile here. And then let's say he miraculously grows 2 inches. So he goes up to 64 inches. What's going to happen to his percentile? Well, it should go up, right? I mean, he's getting taller, so he should be taller than a greater percent of the rest of the male population, and he does. He moves up to the 2nd percentile, or maybe the 3rd percentile. So a little gap. Those 2 inches of growth moved him from maybe the 1st to the 3rd percentile here. But now watch what happens if you take someone who's 70 inches tall. So trying to do some of these conversions in my head. This would be 5'10", 5'10". Right there, they're sitting exactly at the 50th percentile, which means they're at the median. The median is the 50th percentile. They're taller than half the males and shorter than half the males. And now let's say they grow. Would their let's say they grow by 2 inches. Would their percentile also go up by about 2 percentage points like we saw earlier? Let's try it out. We put them in 72. They go from the 50th percentile to the 74th or 75th percentile. They went up 25 percentage points there in terms of percentile. So that 2 inches down here doesn't make a big difference in percentile. And you can see, I mean, the graph is really thin there. But up here, where there's a lot of people, growing an additional 2 inches makes a huge difference in terms of what percent, because we just like passed this entire chunk of the distribution. Whereas here, when we went from, forget what it was, 62 to 64 or something, we just passed a tiny little part of the distribution. So it really depends where you're at on the distribution in terms of how much little changes in your raw score impact your overall percentile. Now, another question you could ask, let's say someone is 72 inches, and you say, what portion of the population are they taller than, of the adult male population? Well, we could say that's about 74, 75%. You could also ask, what percent of the adult male population are they shorter than? And so it's also possible to look for the portion of the distribution that's above whatever percentile you're at. And in that case, you would just have to take 100, or in this 1 minus this number, either 100% minus 75% or 1 minus 0.74, and you'd find about 25% of the males are still taller than this 5'10" height. So that's a basic idea of percentiles. It does come into play quite a bit. Our first daughter was born prematurely and was constantly playing with the percentiles, and that really gave us a sense for where she fit into growth curves and helped make some good decisions.